Hello guys, so in today's video we are going to take a look on Chinese remainder theorem with an example. So in the last video we did a proof of Chinese remainder theorem. In case you are interested in looking at the proof of Chinese remainder theorem, please refer to that video. I'll drop a link in the description. But in today's videos we are going to look at at Chinese remainder theorem through an example. So let us say we are given an equation for which we want to find the value of x. So let us say the equations which is given to us is x is 5 mod 7 and x is congruent to 7 mod 11 and x is congruent to 3 mod 13, and we want to find the value of x. What should be the value of x? Okay, so we want to find the value of x here. Okay, so here the first thing we should check in such cases is like m1 here is 7, m2 here is 11 and m3 here is 13. So the modulus basically 7, 11 and 13. So first we should quickly check whether the GCD of 7 and 11, all GCD of all pairs, GCD of 11, 13 and GCD of 7 and 13. Well, all the GCDs are 1 here, isn't it? So since the GCD is 1, so we can apply CRT theorem or Chinese remainder theorem in order to find the value of x. Now what will be the value of x here? Well, the value of x will be given by I equals to 1 to r, and r here is 3 since the number of equation is 3, ai bi m over mi. Okay, so let us quickly write it down. So m1 here is what? 7. So okay, I've already written down the values of m1, m2 and m3 here. Now what is the value of a1? So the a1s are these values, ai's are that. So a1 is 5, a2 is 7 and a3 is 3. Okay, now let us calculate the m. So m is equals to m1, m2, m3. So what is the value here? 7, 11 and 13. And so the value of m will be what? 1001. Okay, so this is the value of m we have. Okay, now once we know the value of m, so the next task is, and we already know the values of ai's, right? So the known vectors here are, the known things are ai, m we know, mi we know, but we don't know bi's, right? So we want to find the value of bi. So and how do we find the value of bi? So the bi, we can use extended Euclidean algorithm. So let us apply extended Euclidean algorithm to find the values of bi. So let us take a look. In order to find the value of b1, what we are going to do is basically we will say we want to find the GCD of m over m1 comma m1. Okay, and we know that the GCD of this is 1. Okay, again, if you are confused why the GCD is 1, please refer to the video where we have discussed the proof of CRT theorem. Okay, and so since we know the GCD of this is 1, so let us plug the values. So basically what we are trying to say is that the GCD of m is what? 1001. Remember this, 1001. And what is the value of m1? So m1 is what? 7, comma 7 is 1. So let us solve it further. So we can say that GCD of 1001 divided by 7 is what? 143. Okay, so this is basically 1, and since this GCD of this is 1, so we can write it down as 143x plus 7y equals to 1, and we can apply extended Euclidean algorithm to find the values of x and y. Okay, let me use a different notation than x and y since we are using x. 143a plus 7b equals to 1, and a and b are something we'll be able to find it via extended Euclidean algorithm. So let us apply extended Euclidean algorithm to find the value. So the way we will do it is that let us first compute the GCD of 7 and 143. So how does it go? Well, this is 20 times, so this is 3, right? And then 7, which will be 2 times, so this is 1. So once we got 1, now let us rewrite it. Now how the way we can do it is 143 is equals to 7 times 20 plus 3, right? So basically what I'm trying to say is that 143 is equals to 7 into 20 plus remainder, right? Similarly, we can write down 7 as 3 into 2 plus 1. Now let us go from here. So what we can write down is that 1 equals to 7 minus 3 into 2. By the way, this is extended Euclidean algorithm. I have also made a video for extended Euclidean algorithm. If you want to learn it in detail, please refer to that video. And okay, now coming back here, now 1 equals to 7 minus 3 into 2, and what is the value of 3 here? So the value of 3 we can get it from here, which is equals to 1 is equals to 7 minus 2 times 3 is equals to 143 minus 7 times 20, right? And if we solve it, what we will get is 1 is equals to 7 times 41 minus 2 times 143. Okay, now we wanted to find the multiplicative inverse of what? We wanted to find the multiplicative inverse of 143, right? Remember, we wanted to find out b1, and b1 is the multiplicative inverse of m by m1. Okay, and m by m1 is 143, so the multiplicative inverse of 143 is minus 2. Hence b1 equals to minus 2. Okay, we got minus 2 from here. By the way, we are confused from here. Okay, all right, so b1 is known now. Now again we will apply extended Euclidean algorithm, which is this, in order to find the value of b2. So let us find the value of b2. Now b2, as we know, to find the value of b2, okay, we know GCD of m by m2 comma m2 equals to 1. Now let us plug the values. So this is GCD of m is what? 1001, and m2 is what? Let me scroll up to see the values of m2. m2 is 11, so let's plug 11 here, comma 11 equals to 1, and let us simplify it further. So this simply means GCD of 91 and 11 is 1. Now let's do the same thing again, apply extended Euclidean algorithm here. So which is what? Oh, I'm sorry, 11, yeah, 8 times 88. This is 3, I think, yeah, and this is 3 times again 9. So this is what? 2, and this is 1 times, so this is what? 1. once we got 1, so let us rewrite it again. 91 is equals to 11 times 8 plus 3, and 11 is equals to 3 into 3 plus 2. Again 3 is equals to 2 times 1 plus 1, and let us rewrite this. This is equals to 3 equals to 91 minus 11 times 8. From here 2 equals to what? 11 minus 3 times 3, and from here 1 is equals to 3 minus 2 times 1. Okay, so let us expand it further. So 1 equals to 3 minus, and what do we need from here? 2, value of 2. So, and the value of 2 we can get it from here, which is equals to 11 minus 3 times 3. Okay, now let us rearrange it. So this is equals to, this is what? 4 times 3 minus 11. Now let us plug the value of let us plug the value of 3 in this equation from here. So from here we know 3 equals to this, and this is something which we are going to plug it here. So 3 is what? 91 minus 11 into 8 minus 11. Okay, and if you solve it further, what we will get is basically 1 is equals to let me just have it, 4 times 91 minus 33 times 11. Okay, so the value of b2, so we wanted to find this, b2 is this multiplicative inverse of 91, so the value of b2 is 4. Okay, so the value of b2 is 4. Now let us work on the value of b3. Okay, so we want to find out b3. Okay, in order to find out b3, we know that GCD of m upon m3 comma m3 equals to 1, which is essentially GCD. Let's plug the values. M is 1001 and m3 is what? M3 is, I think, what was m3? Okay, m3 is 13, right? And 13 equals to 1. Okay, so this is basically saying that GCD of I think 77, yeah, comma 13 equals to 1. So now let us apply Euclidean algorithm here again. 77 divided by 13 equals to what? It's 5 times 13, 1 time. So this again we can write it down as 77 equals to 13 into 5 plus 12, and 13 equals to 12 times 1 plus 1. So now this can be written as 12 equals to 77 minus 13 times 5. Okay, and let's work on this. 1 equals to 13 minus 12, and this is basically 1 equals to 13. And what is the value of 12? Well, the value of 12 is this. Let's plug that value. 77 minus 13 times 5. So what do we get here? 1 equals to, so 6 times 13 minus 77. So, and what do we wanted to find out? We wanted to find out the multiplicative inverse of m over m3, and m over m3 is what? 77. So we wanted to find out this multiplicative inverse of 77, and the multiplicative inverse of 77 is minus 1. Okay, so b3 equals to minus 1. Okay, having known this, now let us compute the value of x. So let me just rewrite it over here. So we know that b3 equals to minus 1, b2 is equals to what? b2 equals to 4, and b1 equals to is the value of b1? -2. Okay, and we know with the help of CRT theorem, x will be given by I equals to 1 to 3 m over mi ai into bi. Okay, and let me rewrite the equation here. So the equation given to us was what? X is congruent to 5 mod 7 mod 7, x is congruent to 7 mod 11 mod 11, and x is congruent to 3 mod 13. So the values of a3 is 3, b2 is what? Sorry, a2 is what? a2 is 7, and a1 is what? 5. So let us, now we know the values, all the values, and we already know the value of m. We know that m equals to 1001. So let us plug this value. So this we can write it as x equals to m upon m1 a1 b1 m upon m2 a2 b2 plus m upon m3 a3 b3. Okay, so this simply means x equals to m is what? 1001 divided by divided by 5. Okay, I'm sorry, divided by 7. M1 is 7, and what is the value of a1? A1 is 5, and what is the value of b1? B1 is -2. Okay, plus m again 1001 by, what is the value of m2? 11, a2 is 7, and b2 is what? 4. Similarly, 1001 divided by 13 into a3 is what? 3, and b3 is -1. So if we solve all this, what do we get is x equals to, well, x equals to 887. Okay, so this is the solution. So this is the first value of x for which this equation is satisfied. So that is how we apply Chinese remainder theorem in order to get to a solution. So that's about this videos, folks. If you have any confusion, questions on this video, please feel free to drop it in a comment. I'll try to address them. Thank you.